Here's an introduction to a very important subject, which is logarithms. So what do I mean by logarithm? So the logarithm of a number can be defined as the exponent to which another fixed value, which we call the base. So we've got an exponent, we've got a base, must be raised to produce that number. So another way of saying it would be, how many times, which we're going to call x in our nomenclature here, do we have to multiply the base, which we're calling b, to get to this number y. Now here is kind of an equation that you have to remember. This is very important. So if we've got b to the power x, this is the base b to the power x, x is the exponent, is equal to y, then that's the same as saying that the logarithm in base b, so log, and then we've got a subscript b of y, so I'm writing this y in brackets, is equal to x. So how many times do we have to multiply b by itself? So that's why we've got the exponent here to get to y. So this is really important. So let me just show you a couple of examples. So how about the log in base 10 of 1,000? What is that equal to? So that's the same as saying how many times do we have to multiply 10 by itself to get to 1,000. And indeed we know that 1,000 is 10 times 10 times 10, or 10 to the power 3. And so 10, we can fill in this equation here, so 10 to the power 3 is 1,000, is equivalent to saying that a log in base 10 of 1,000 is equal to 3. There's the first example. Now let's have another one. So how about the log in base 2 of 16? What is that? So that's the same as saying how many times do we have to multiply 2 to get to 16. So in this case we've got 2 to the power what is equal to 16. So we're looking for the log in base 2 of 16 is something, and we know that 16 is 2 times 2 gives 4 times 2 gives 8 times 2 gives 16, so that's 2 to the power 4. So now we can fill this in, so 2 to the power 4 is equal to 16, is equivalent to log in base 2 of 16 is equal to 4.